Hey, welcome back to RamZland. Today I want to show you how to electrolyze water with just some silverware and a 9-volt battery. Check this out. So all I'm using in this first demonstration is sodium hydroxide to create an electrolyte solution, half a cup of distilled water, 2 spoons to serve as electrodes, a 9-volt battery, and a couple of wires with alligator clamps. The first step is to stir in 1 spoonful of sodium hydroxide. This is what sodium hydroxide looks like. And this is just simply adding some ions to the water. Since water is a poor conductor of electricity, those sodium ions will just increase the flow of electricity to help split the water into hydrogen and oxygen. The next step is to clip each spoon to one side of the glass with your alligator clamps. Okay, now you're ready to hook up your battery. So the negative side is the cathode. That's the side that's going to release hydrogen. Hydrogen in this experiment is being reduced. And the positive side is called the anode. And on that side, this spoon over here, it's going to split the water and release oxygen. Oxygen is what's being oxidized in this experiment. Now, since water is twice the amount of hydrogen than oxygen, you're going to produce more hydrogen bubbles than oxygen. And we can see that already. So over here, this is the hydrogen side. That's hydrogen gas being released. And over here is oxygen. Those are oxygen bubbles being released from the water. This process is known as electrolysis. You're using electricity to decompose water into hydrogen and oxygen. Here's another option. If you don't want to use silverware, you can use pencils because the graphite works as a great conductor. Some cardboard. I'm still going to use a 9-volt battery. Sodium hydroxide to create an electrolyte solution because those sodium ions promote the flow of electricity in our water. And just like before, I'm going to stir that up. But instead of using silverware for the electrodes, I'm just going to use a pencil on each end. So for this method, I'm just going to poke a pencil in the middle of the cardboard, one for hydrogen, one for oxygen. And then I'm going to lower that into my beaker, just like that. And then I'm going to connect my electrodes to my battery. Next, you're going to clamp your alligator clamps to the top of each pencil. Remember, the negative side, the cathode, is going to release hydrogen gas. And the positive side, the anode, is going to release oxygen. And let's zoom in on those pencil tips and see what's happening down there. Okay, so again, the pencil on the left is hooked up to the cathode, so this is hydrogen gas that's being released over here, and the hydrogen is being reduced as it gains electrons, and over here, hooked up to the anode, that's releasing oxygen over here, and the oxygen is being oxidized as it's losing electrons. Since the stoichiometry of a water molecule is H2O, you're having twice as much hydrogen as oxygen that's being released in this electrolysis experiment. Of course, when you're learning about electrolysis, you've got to test the gases. And so I'm going to use a Brownlee apparatus for this next demonstration. One side will trap oxygen, the other side will trap hydrogen in these test tubes. I'm still using a solution of distilled water and sodium hydroxide to create an electrolyte solution, but I'm going to use my DC power supply to run a current through this solution so I can trap hydrogen and oxygen in these test tubes and then test those gases. Check this out. Okay, so my DC power supply is adjusted to 12 volts. You can see the negative side over here is producing hydrogen gas. The positive side over here is producing oxygen. And already I can see more hydrogen gas is displaced in this test tube than oxygen in this test tube. It should be a 2-to-1 ratio. Let's take a closer look. Here you can see the cathode is really producing a lot of hydrogen gas. All of this is gas right here. And on the side with the anode, you can see just a little bit of oxygen gas has been produced over here. Clearly half as much as the hydrogen gas. Okay, so let's review what's going on with the pencils. One side is hooked up to the cathode, that's the negative side. That releases hydrogen gas. The other side is connected to the anode, that's the positive side that releases oxygen gas. So remember, this is a reduction oxidation reaction where electrolysis splits the water into hydrogen and oxygen. So on this diagram, you can see again the negative side, that's releasing hydrogen. Hydrogen is being reduced. And on the other side, that's positive, that's called the anode, and oxygen is being released. And again, oxygen is being oxidized in this experiment. Okay, we're almost ready to test that hydrogen gas. So you can look at how much hydrogen gas has been made. Almost the entire test tube is filled with gas. Whereas on the positive side, the anode, you've got half as much oxygen has been produced. So of course, I want to test that hydrogen gas. It should make kind of a popping sound because we know that hydrogen is flammable. So I'm just going to take out the test tube from the side with the cathode that's producing hydrogen. I'm going to lower that over the flame. Here we go. Oh, definitely had hydrogen gas inside. Of course, I want to test the oxygen as well, and my test tube that's hooked up to the anode is almost filled with oxygen. So I'm going to light this splint and I'm going to blow it out, and I'm going to see if I have enough oxygen in that test tube to reignite this burning splint in the test tube. Let's find out. Let loose this so it's completely out. Let's see what happens. Oh, it reignited. Look at that. It's burning in the test tube. So let's look at the overall equation for this reaction. We start out with water, H2O, and as we pass electricity through that solution, it breaks down, it decomposes into hydrogen gas, that's H2, and oxygen, that's O2. Notice that there's twice as much hydrogen, 2H2, as there is oxygen in this reaction. Remember, the hydrogen, it's being reduced as it gains electrons, and the oxygen is being oxidized as it loses electrons.
enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.